This video is sponsored by me. We're hosting a track day NCM Motorsport Park April 4th, 2021. Come out, be there, have fun, enjoy the video. Hello everyone, Jackie Ding here. We're back at Verus Engineering for episode 2. This time we've finished all the 3D scanning, we've finished the designing work, and the parts are in production, which is really exciting. And we're gonna show you exactly what we've done. And I think we've done a decent chunk to help really not only balance the car, but improve its overall aerodynamics properties.
Hi, Paul.
Hello.
Sorry to bother you again.
Yes.
But what do we have?
So what we were looking at is, so these are both cars. So this is where it started, and this is the current one that's going to be being ran. So obviously the main difference is going to be in the front splitter.
Well, Paul, you say that. Everybody who I've shown the model to, they say this splitter looks the same.
Well, yeah, it probably does. So from the top side, it's going to look very similar. We kept the same sizing, basically, because you guys were right on the edge of the rule set already, so we couldn't make it larger.
Cuban, we didn't cheat.
It's actually the exact same size, so that you'll have no issue of cutting anything or doing anything like that. The only thing that's a minor difference is some of the area that was taken up by the 3D end plate was added onto the side and made the flat section of the splitter a little bit longer and went with flat end plates instead. So that's the only main difference on the outside. But on the bottom is where all the changes happened. And so this image, we are looking at coefficient of pressure. So on this scale, we want to be further down this way. So the -1 area is better. And as you can tell, this is the improvement from before to what we're running now.
So what we're looking at is like the more deeper the blue, the bigger like the low pressure is, and
The more
that
downforce.
translates to more downforce.
Correct.
That's a crazy difference if you look at it. That's really big.
Splitter mount's gonna love it.
Yes.
Yeah, but luckily we designed it to enable the same splitter setup as like the mounting setup as before, maybe just a little bit cleaner. We also have the CAD model of that, so
Yeah, so really the tunnel system got completely revamped, right?
yes.
Can you actually walk us through like what each of these tunnels look like and what they, or like which ones are for what? Because every time I look at this picture, especially, it looks like there's a million of them, and
Yeah.
I'm not sure. Like I get really fussy over what part pointing to where. I think.
All right, so what's pretty common that most people end up doing is something similar to the main diffuser, which is goes in between the end of your fender liner and then the tire, and that looks more like what people would assume is like a diffuser.
Right.
Starts off wider, gets narrower, grows in size. It works very similarly as like a rear diffuser tunnels. If you're running like a big floor tunnels, that's basically what that type of diffuser is. You run that because you don't have the issue of a tire in the way. So when you have a tire in the way, I don't run that style because it doesn't work as well. So we control these off math formulas. I'm not going to get into exactly how we do that because that's a little bit part of the trick. But this is a different type of math formula than these. They're a little bit different. This is a small one. This does help too. It is designed similarly as that because, again, there's no tire in the way. Same with the center. So the center diffuser is also designed like that. They're shaped differently, so you see this actually gets wider instead of narrower, but the actual formula that controls it is more similar to that. So these, because they go in front of the tire, we're actually doing something else. We're actually creating more of vortices in there instead of just bringing air up a ramp in essence. You're not going to get as much performance out of these two as you would, say, this one, just because of the tire. But if you're not utilizing the air in front of the tire, you're losing a lot of performance increase you could then have.
So really, the big improvement or big change from version 2 of Splitter that we had was first we added the big center tunnel.
Yeah, and I can show front view, so it's actually higher.
Yeah, it's raised up as well.
Yeah.
So it's higher up, so you don't have to worry about even if you're on the ground. Yeah. It doesn't.
Right. So that
I think that's one of the big misconceptions is like a lot of people think the lower the splitter, the more effective it becomes.
To an extent.
To an extent,
to an
yes,
extent.
until you kind of touch the ground or
Yeah.
the angle of attack is too much, it stalls the
And then there's
splitter
nowhere.
thing. It just doesn't work at all.
Yeah, so it's. I don't know exactly how low that is on this, but there'll be a point where you get to basically, in essence, choke flow.
Yeah.
and that's what you're talking about.
Yeah.
It doesn't actually have to fully touch the ground, but when it does touch the ground, you basically take the area of where the air is going to zero, and you get zero airflow, and you lose downforce, and that's one of the reasons we have our grind plates on here to help keep it off too. So like you have these on the leading edge, you have these so when you actually come straight down, you're not going to damage the splitter, and then you have these guys on the side that also help the end plate, because the end plate does stick down, but it's designed to grind also. So
Right.
any of that grinding the ground is not an issue. You obviously don't want the blue area to
Okay.
grind.
It's kind of the upside down view, but
Yeah.
shows it probably the best. That like, whereas before we had only a pair of tunnels on the sides, now we have one center one, a big one that goes towards inside of the wheel, two on each side that goes to the tire, and then one small one on the very edge.
Yep.
So that's, I think, where most 90% of the tricks on this aero kit has gone into the splitter.
Yeah, because if you look at the old splitter, you can see half the tunnel when it's like directly in front of the tire.
Yeah.
You can see the pressure difference between the inner half and outer half.
Yep.
Yep.
And now instead of like having one tunnel that run both, might as well have separate tunnel for separate function.
Yep.
Obviously, it's more complicated to produce. Spage complained to us many times, and we made him anyway. Made him do it anyway. So, it's pursuit of excellence.
Yeah, and the big thing with this is making sure that everything works well and is survivable, which is
Yeah, about that. That's
Like-
very important.
like-
We'll find out this year.
yeah, like that's why one thing that we've kind of switched to is like this leading edge grind plates on here.
Yeah.
It's a little bit different than when you see on like an LMP style car. They do it a little bit different, but these cars are honestly different than those. So some of the tricks kind of go hand in hand, but they're limited by rules and what they can and can't do.
Right.
Also, sometimes we're not. So we're able to basically shape these also, so it helps with on the leading edge, as you can tell, like it follows it and then comes back down.
Okay.
So it is actually lower down to the ground than the actual splitter itself, so it gives you plenty of room. The bolts aren't technically in here on this one because this is the manufacturing model, but you still have the holes for where it's going to be mounted with socket heads, which they're plenty low. So you have plenty of area to grind down before you would even get to the splitter itself. So it allows you to be a little bit more aggressive towards the splitter and not worrying about damaging it. Which also helps because the car makes a lot more downforce. And then you can kind of see where all the diffusers are working along here. That's the big difference between, say, like up here at the top, like there's not anything going on because there's only one tunnel comparatively to all the tunnels across here.
Yeah, that's the biggest change, I think.
yeah.
And obviously the center, like I told you, like the center, because there's nothing right here.
Yeah. It's all
This,
clean air.
yeah,
Yeah.
it's all good air. It's good air no matter if you're turning, like you're in high yaw. Doesn't matter. That's always going to be good air right in the center. This is pretty much guaranteed that, and you're going to get that even if you're running super low to the ground because it's up a little bit higher
raised
also.
up. So that kind of that's kind of similar to what we see in race car designs these days, where they kind of have the splitter curves up towards the center, correct? Trying to I think what Alex said was for it to not be pitch sensitive.
Also that.
Yeah.
Right.
Yep. That, and you don't end up having it helps eliminate the porpoising problem down the track. So this helps with that. It's not going to 100% eliminate it because downforce cars are more prone to porpoising in general, but this will help. One thing we can look at is if we're curious where like all the downforce is coming from. So this plot right here, this is basically a coefficient of pressure, but normalized to the z direction. So everything you're looking at, if it's red, it's creating lift. So every place that's red is going to be creating lift. Every place that's blue is going to be creating downforce. So top of the wing's creating downforce, which makes sense. Top of the splitter is creating downforce because it's higher pressure. You get low pressure up here, so you're going to be creating lift. Top side of side splitters also create lift. That's why you don't really see that's why they're usually fairly neutral until you start getting into turning and yaw conditions. Obviously the underside, that's where you can see it looks very similar to the CP plot on the bottom side just because it's most of the bottom is creating downforce.
Right.
Except the tires, so you can see where the tires are creating lift, and the drag aspect is always an interesting one to look at. And this is where you can really kind of see the difference between, say, a wing and then underbody aero. So a lot of times, like, wings are great at adding downforce, but wings, no matter what, are going to create drag. And you can kind of see the drag. So this is just on the top side, creating drag, and then on the bottom side, creating drag. Obviously, the whole back of the car creates drag, but then compared to, like, the splitter, remember how much downforce all this was creating? But
It's almost
no drag.
Because of force applies to the actual surface of it. So if you have an angle that's up, like, maybe say 7 degrees, and then you take a vector normal to the surface and it goes down, well, most of that vector is actually pointing down and not rearward. So that force that's being applied mainly is downforce and not drag. So that's why you can get away with it on, like, a splitter and things like that versus, say, a wing, because a wing is going to have that entire back curve surface. We can also look at
Surface flow?
Yeah, surface flow. You can kind of see how you can see the separation off the vents, especially right here. This has like a cool cattail coming off of it.
Wow.
And this is from air coming from the inside that kind of bubbles up over right here. And you can see as it goes down.
What's cool about this is you can pretty easily verify by just not washing your car.
Yes.
Because we'll overlay pretty similar to this.
Yes.
I do have one question from the YouTube comment section that I've been meaning to bring up. People have been wondering, since there's such a dead water region inside the car, right? If you open up the rear hatch and take out that glass and let the air flow out, wouldn't it help? I know the answer is no, it wouldn't, but, like, can I have some proper answers?
It could, and I don't know if it actually would or not. It depends what your definition of help is.
Right.
If your thought is that it will help decrease necessarily drag because of the inside of the car, I would say no, it doesn't really help. But if you want to use that air to affect something else on the car, then yes, it could help if implemented properly. So, like, right along here, it's fairly neutral, but depending on how you set it up, you could actually, because this is going to be some higher bubble in there, you could duct it out of here and maybe help better flow to the wing. There are things you could do like that. You could actually duct it out behind the rear bumper.
I know William ducked something from the bottom of the car to the rear bumper to reduce the weight.
Because if you took some of the air from inside the car and, say, dumped it out like where your license plate is or around where the Toyota symbol is, just putting a hole in there and just letting air go through there, you're going to decrease
Alright, I guess we're putting a hole in
the
there.
drag in those areas. So
Fuck it.
The answer wouldn't be that, yes, opening the rear glass is automatically going to decrease. It really just depends.
Yeah.
Like everything, it's how well you implement the solution.
So let's look at, if we could, the side skirts, the side splitter. Also something that we're been trying to do this year.
So it's not going to really help with downforce creation in what people would normally think of as just driving straight. Where it does help is when you're in yaw conditions, turning, and air's coming in the side. Instead of spilling over underneath and ruining the flow to the rest of the car, or also hurting flow to the front splitter. So if you have air just shooting into the side right here, it could negatively affect your splitter, because remember, air back here is going to affect what it's doing up here.
Yeah.
Just different. Like if you think of it like as a pipe, and you have pipe up here and you have a clog down here.
Yep.
Well, this is going to slow down based on the flow that you can get through the pipe.
Right.
It's a similar concept, obviously not the same because the underneath isn't a pipe, but if you make this area harder to flow air through, then it's going to hurt the front splitter.
Right.
So that is really where you're targeting the performance on the side splitters. So side splitter is something very easy to add that will improve the performance in the corners and yaw conditions. So you can't control the weather, so you could have crosswinds that day. And what would be terrible if you had high crosswinds and then it started horribly changing the way the car acted on front aero. That'd be terrible.
Right.
So that basically helps with these type of conditions. But as you can tell, like, there is low pressure on the top side, which creates lift, and there's low pressure on the bottom side, which then creates downforce. They're basically neutral as downforce creating themselves, but that's not the purpose. The purpose is to help the overall car in all conditions.
it by itself doesn't create downforce, but it helps others things up front to create more stable downforce. Would you say that?
Yes, that would be a good way to describe it.
Yeah, I'm actually very interested. Remember that little tip vortice from the
Yep.
front end plate? Like, what does it do with the side skirt now?
Yeah, if we could look at the streamline. Oh yeah, and by the way, the end plates are slightly different. If you look on there, we do have added like a new tire spat on the orange part as well.
Oh yeah.
Oh yeah, that's very.
Yeah.
And those help a ton, almost always. Except I've only seen one case where they don't help, and that was on a funny car. So that's not really how most people run their cars.
Funny
so-
cars.
The drag cars.
Yeah.
Yeah.
Yeah, it's the top fuel, but that look weird.
I think compared to the first thing, compared to the last one, the first thing I see is I think the vortice got pushed out more.
Yep, and it's smaller. I think the push out is probably from the,
The tire spat.
Yeah, the tire spat.
Yeah, if
Yeah.
you look at it, like after it passed through like especially on the driver's side, right after it passed through it immediately got pushed out a little bit more than the
Yeah, and one thing
configuration.
you'll see is from the partially from the diffuser tunnels too, because these tunnels are actually spitting them out.
Whoa,
Oh.
I see.
It helps push kind of everything outboard, which is kind of the goal. With you want to get all of this airflow kind of out. Depending on like if you guys had more open rules, you could reuse some of this. Obviously not the ones that hit the tire, but this inner one you could actually kind of re-energize that flow and use it back underneath the car if you guys had a different rule set. Obviously because the rule set's limits on what you can do, you can't really do that. So because of that, you want to get that air out. So that's part of the reason kind of it's all spilling. The tire spat is pushing
Yeah.
air outward too. It's an isoplot. So this will be areas on the car that has a total pressure of 0. So basically like air that's used up, and you can kind of see,
So this is like turbulent area,
This is,
yeah, coming out. So,
detached flow.
This is Supra on a Play-Doh.
so you can see all of that air kind of coming out that side. That's why those streamlines are coming
Right.
way more out.
Right.
Someone explain to me what this does. What this plot does.
So
Exactly,
basically,
I'm
it's
kinda
where you can't really find like a directional flow. It's all turbulent. So all the blobs like you see there,
Yeah.
it's just gonna be like all massively turbulent.
Yeah, it's
Basically,
super dirty.
Yeah,
super,
super
super
dirty.
dirty.
So those are the dirtier.
Yeah.
like really, really dirty area.
Okay.
Which makes sense. It's coming out of areas that you would assume are going to have worse flow.
Yeah.
You're going to have it coming out of the tires because obviously they're moving. It's going to be coming out of the vents, out of the center, a little bit on there. Not a whole lot on the end plates, but obviously from that front block, it's coming out that way. Well, and you can in one way you can kind of represent some of this is a lot of this area that you see is going to be causing drag.
Okay. Then that makes sense.
Which you can see why, like the back of cars. That's
Yeah.
why I was saying if you reuse some of that air on the inside and spilled it into this area
To
Yeah.
reduce that
cleanly,
bubble.
you could reduce that bubble. That's why given a lot of people hate the car, I personally think the car is super cool. I just don't think they had enough time to develop it. But the Nissan's GTR LMP car,
We
I
just-
think we were
we're
just
just
talking
talking
about
about
that
that
on the
car
way
right
here.
here. Yeah.
that car was awesome aerodynamically.
Yeah, I think the data wasn't that much far off the top speed of the LMP1 car without the hybrid on the street.
Yeah.
Was like pretty up there with like
Yeah.
half of the horsepower.
Yeah, it was.
That tells
it
you
was-
how little drag that thing makes.
Yeah, it was super efficient, and that's because basically they were running a ton of through ducts. It'd be very similar, like open, like say instead of running air through a radiator and then ducting out the top, you duct it straight through the car
Yeah.
and
Okay.
out the back.
Yeah,
type
that
of
thing
area.
is that thing's one
Right.
of those like Le Mans super special. It
Yeah.
probably doesn't work anywhere else
I-
just because Le Mans is so
I wish Nissan
Different.
had the money.
all the
But
time.
they, yeah, all the time. But they had neither.
yeah.
That's cool. And can I just say, I think the overall, like, the vortice size got reduced as well.
Yeah.
Like that.
But yeah, you can kind of see how.
Oh yeah, you can see how, like, it actually pulls it out of the wheel well.
Yep.
Interesting.
Wow.
That's why tire spat almost works all
Yeah.
the time.
Tire spat almost always works.
I that's one of the things I would say is usually a go-to that almost always works. Luckily, with an Aero, you can't always say something always works, but something like that almost always works. And we found they're actually usually they usually help more than say dive planes. Like that's a tiny little device on here.
Yeah, like if you don't look at it
It's like
closely,
a
you can't even.
niche.
Look at
Yeah.
it. It's
Yeah.
basically this width of our front lip anyway.
Yeah, it's tiny. Yeah, it's not very big. In essence,
The
it's small.
Question. I know sometimes that in grassroots time attack especially, people tend to run like really big, and they start like pushing the wheel spat like quite a bit further out. Is there like an optimal size that you would say, or is it more like a per application kind of deal?
A lot of it's per application. Usually, I think a lot of people go a little bit bigger than they need to. However, what I would say need is different than somebody else's. Like, unless your goal is as much downforce as possible all the time, I try to look at the efficiency and how the total efficiency changes.
Right.
So usually if you do bump that out more, you're going to gain more front downforce, but in my opinion, it's not very efficient front downforce, because if you bring that out further, you're going to increase the pressure on this front side, which is going to increase the CP, the plus side, but you're limited on how high that number is going to be able to go. So you're going to increase a little bit, but in essence, you're not going to be creating that much more downforce with how much more drag you're going to get by increasing the overall area. Like, adding these added no frontal area to your car,
Right.
because it's sitting right in front of the tire.
Right. So I do know this. Drag is a formula that is affected by your overall frontal cross-sectional area.
Yep.
So the larger your cross-section area is, the more drag you're going to have. So, whether it be adding wings, aero devices, bigger, smaller mirrors, etc., that kind of all plays a factor. That's also why the NSX, freaking Amir's car, so small, so kind of short, that it has a smaller area and therefore a little bit less drag, at least just from that component versus a bigger car like SUV brick, right? So I did have some ideas. I did the whole center exit exhaust because we wanted to do basically a pair of tunnels going down basically alongside the exhaust to basically the rear axle line, and we worked up quite a few designs, and we even sent it to Space to have it have the cost assessed. There's gonna be some stupid amount of money just because we'll be able to show that design a little bit.
Yeah.
And ended up going against it we're gonna retain what we already have currently. It's an efficiency thing, I think. Cost versus actual effectiveness, if that makes sense. So this is what we actually made. Well, we tried to make.
Yeah. So this does improve performance, but because you are limited on how far you can go forward on the car and the car itself, you're limited on how much height, in essence, you get off the diffuser itself. So there's only so much performance to be gained. And with the expense and the time and everything it takes to get that ready, you pretty much decided that it doesn't make as much sense as spending that time in other areas.
There's also the fact that we can't use like a full flat bottom, so that kind of really limit your airflow going to the diffuser.
Yeah,
in the first
ideally,
place.
I'd like to extend these all the way basically to where the front diffuser sits, the front splitter, and then it's one full Venturi tunnel all the way.
Yeah, and that's where you can start to really make a ton of downforce.
So can we take a look at the actual gains on the numbers with this one? I almost went to pull the trigger just for the looks, because it looks so good on the back of the car and everything.
So you can look at, one way to look at forces on a car is looking at the individual forces. But remember, just because your diffuser, say you make 10 more pounds, one diffuser to the other on the actual physical component, that doesn't mean it's 10 pounds on the overall car, because a better diffuser could improve performance to, say, the front splitter. Even though it's 10 pounds on the diffuser, could be 100 pounds on the car. At 120, it was about 40 pounds, and then 80 pounds at 160.
80 pounds of downforce. This is on the overall car, correct?
Yes, which is a better way to kind of look at it. And
I guess we will revisit that idea after COVID.
We have to revisit that idea after.
100 pounds, 100 pounds. That's like a U.
That is a 3/4 of a me.
Yeah.
We'll quickly touch on the cost. Basically, the diffuser, producing that piece was gonna cost us more money to make that diffuser than it is to make the entire front splitter.
Yeah, and also you can buy Verus diffuser for not a lot of money.
Yeah.
That works
and it-
slightly not as good, but like 10
It's
times
more
cheaper.
universal. That's what shall we
It's
say.
also
that.
10 times
Yeah.
cheaper.
It is like easily 10 times cheaper.
So this is like, it's hard to tell on the pressure area
Yeah.
on it, which is why looking at the diffuser itself makes it kind of difficult to tell. But like, this is the difference from this. So this is the difference between the runs that we were just looking at the data.
Right. So this is the promised land splitter,
Yeah.
and that's what we currently have, both on the same splitter and everything.
Yeah.
But at one point, if we're building like an all-out, say
Yeah.
like flat bottom everything,
I-
this probably
look,
gonna
I think
revisit this
Yeah.
idea.
Well, and here's another. Like, this is one that actually created more downforce, but it wasn't as efficient.
right.
It was a lot bigger.
Oh yeah.
So you
my
could. That was one of the that was one of the huge ones.
Big boy.
This
So let me get
is
to the
what
back
I
picture.
this is what I told Paul to make.
Yeah, but it's so people who like the one thing is when you say like, oh, it won't make, it's too aggressive to make downforce. It really depends on kind of what you're talking about because like obviously this is making downforce. You can tell just based on the pressure. Like
Yeah.
you go to here. This is CPZ. This is making downforce. There's no doubt about it.
Right.
But you look at this. Look how separated it is
So
because of
like
how
back
big the
half of it
expansion.
is like
It's vorticing up
Yeah,
over there.
it's
Yeah.
super detached. It's
Yeah.
it's this would be there's it wouldn't be my recommendation. The one in the middle I think could be one that maybe it really depends on. Ideally, you would want to run your car with the splitter and see with all the new downforce and your new power that you're making, and then decide if a little bit more drag for a little bit more rear downforce might be beneficial or a
Right.
little bit more overall downforce. Because there is another one. This one was kind of like in between the aggressiveness, but it like the flow
Yeah,
wasn't
flow's
nearly
better.
a lot better.
How does it look from the outside?
Still pretty aggressive.
still pretty big.
I like it. I'm making this one.
So yeah, so it's still pretty similar. It's definitely higher up, but it stays a lot more attached. But it still creates more drag. So the L over D is worse than the one that we designed for you because you were looking for overall efficiency. Like you were concerned with drag too.
Yeah.
And since those increase drag more so than the downforce they created, it just didn't make as much sense.
Then I think it's important to think like when designing aero, like what is your acceptable level of drag for the downforce you're trying to trade? You know what I mean? Like you're not just trying to gain free downforce. Well, that's kind of tough a lot of times. Versus like, okay, if I'm willing to give up 1% of drag for 5% downforce, where can we do that, right? It's a give and take. Nothing in life is ever free.
Comparatively to where we were starting, we're at, so at 100 mile an hour, we're at over 200 pounds more downforce than where we started, and we're at 10 pounds more drag.
Wow.
So that's where and all that gain was in the front, and we also went from 29.8% front balance to 59.1, which then you can tune with your rear wing.
Yes. So for 10 pounds of drag, we found basically 200 pounds of front downforce
At 100.
at 100 miles an hour, which the car goes to reasonably often.
It's there multiple times per lap.
Yeah. So that's where I see as being really helpful. As now we can actually trim or add a little more rear wing to actually balance the car out.
Yep. We were doing 200 pounds more at 100, which we just said, and then we were at about 300 pounds more at 120, and then at 160, which is what I would say would be the max of kind of what you guys
Pretty
would
much.
see at a high speed track. You're about 500 pounds more downforce, and then on the drag side of things, about 10 pounds at 100, which we said, and then at 120, we are at about 20 pounds, a little less, and then at 160, we are 32 pounds. So
32 pounds increase for what is like 500 pounds.
With the new splitter installed, we're gonna have to stand on at the both at the same time just to verify it stays at the 160. It's not gonna be like one jacketing test. It's gonna be one jacket plus Alex test.
So,
you should have a few people stand on it just to make sure it's all
Okay.
good. We gave plenty of good support on there on the actual model, so it should be like with these built inserts in there, it should be pretty stout.
Got it.
because this is going to hold up most of the force. Because when you saw the pressure, it was like all like the big chunk was along here and then also along here, which that'll help with. But this is going to be.
That will be the main kind of force.
Yeah.
Okay. Translate that to the chassis. So.
Yeah, and your brackets were like all the way along these areas, which is why we left all of this space open to make sure that you can properly support it.
I think one of the things I'd like to look at kind of is the rear bumper. So one of the things we're thinking about as a way of reducing a little more drag is rear bumper cut. Now, I know in the S2000 we did the full flat. On this, we're not going to go as aggressive, but what we're going to do is looking into potentially chopping off parts of the bumper, maybe not as much to the basically to where the diffuser is, to allow for rear wheel extraction. Would that be the right word?
Yeah. Basically, it's not going to gain downforce. It's all about trimming drag out of the car. You get a buildup of pressure around the tire, and so just letting that air dump out is a good thing. You can try to reuse that air, like you'll see on like DTM cars. They have
like the wheel boxes.
Yeah, like there's things you can do. I think a lot of that is because they're limited on rules. They're looking at optimizing every small detail. You could spend a ton of money to make something super cool for small gain, which could be a big gain if that's what you're like. If you're limited on your rule set, that could be a huge gain. This is in essence where the cut's at, which is, I believe, right. Like there's a light right around in here or something.
We'll get rid of that.
Yeah, I think I measured. I looked at our car specifically to see like where's a decent area that you could actually cut at, because obviously with just the scans, which we don't really know what's inside of here. So I know you guys are working on moving some stuff.
So basically on the passenger side of that, driver's side there's nothing, which is perfect. Passenger side we have the evap canister. So yeah,
pop it up pretty
what I like with the rear wheel cutout is it kind of reminds me a little bit of the GT3 cars. Yeah, like all the modern kind of GT3 Astons or the BMWs, they all have like a little bit of a rear wheel cutoff. So
yeah, it's to gain efficiency. That's the main thing. You're not going to be creating down. Like even if you like put like dive planes in this, I don't know even what you call winglets back there. You're not going to really do a whole lot because it's dirty air anyway.
It looks cool. I would put the winglet there.
Yeah, it looks like, don't get me wrong, I think it looks cool.
Liberty, was it Rocket Bunny or Liberty?
Yeah, they put the wings like behind the tire.
Yes.
Yeah,
we put like 8 different wings on 4 on each side.
Yeah, it's not going to really do anything, so it's kind of it will definitely create drag, so it's like, do you really need to do that?
I don't think drag was in the design prompt for Liberty Walk.
No,
I don't think.
They probably aren't looking at data to make their design decisions, I would say.
So they were looking at the data on Instagram, I'll tell you that.
They're looking at Instagram data.
That's better business model.
That is
that's a better business model, let's be real.
That's kind of our 2021 package, I think.
Yeah.
What we'll dub the TA90 V2.5. We're going to have so much more front downforce that this guy is actually going to get the car a bit oversteery. So I'm looking forward to that. Yeah, we'll find out as we're coming out of the pits. If I spin out, witness me.
Well, then we'll know it's making a good amount of front downforce. So
there's like, Paul, it's working a little too well.
Can we make another splitter now, please? I might, for the first time, ask Alice for more wing at the back, please.
That would be a good thing.
Thank you all so much for watching. Thank you, Paul. Thank you, Verus.
No problem.
See you next time. See you at Coda.